Hello students, welcome back to my channel. In this video, I am going to discuss in detail about the Bohr's atomic theory. Bohr's atomic theory was proposed based upon two important theories, namely Rutherford's atomic theory and Planck's quantum theory. So, Rutherford's atomic theory and Planck's quantum theory are the basis for the development of Bohr's atomic theory. So, coming to the important postulates of Bohr's atomic theory, the electron in an atom revolves around the nucleus in circular paths called orbits. So, let us draw the structure of atom according to the Bohr. It is the nucleus of an atom, and here these circular paths are called as orbits. So the electrons revolve around the nucleus in circular paths called orbits. Each orbit is denoted by principal quantum number n, and the value of n varies as k, L, M, N, O, or 1, 2, 3, 4, 5. So, each orbit is denoted by the principal quantum number, small n. The value of n varies as k, L, M, N, O, or it can also varies as 1, 2, 3, 4, 5. That means if the orbit is M shell, then the value of M shell is 3. If an electron is present in N shell, the orbit number is 4. So, according to Bohr, each orbit is denoted by principal quantum number small n. So, how the value of n varies? The value of n can be represented as k, L, M, N, O, etc. Or the value of n can also be represented as 1, 2, 3, 4, 5, etc. As the value of n increases, as the value of n increases, both the size and energy of the orbit increases. So as the value of n increases, it is very clear from this picture. So if the value of n equal to 1, here the size of the orbit is small. At the same time, if the value of n is equal to 4, the orbit size is large, and hence the energy of the orbit is also high. So in that way, as the value of n increases, both the size and energy of the orbit increases. As long as the electron revolves in the fixed orbits, the energy is neither emitted nor absorbed, and hence these orbits are called as stationary orbits. So as long as the electron revolves in that orbit, the energy is neither emitted nor absorbed, and hence the orbits are called as stationary orbits. So as long as the electrons revolve in an orbit, it does not radiate energy. That means the energy is neither absorbed or nor emitted, and hence these orbits are called as stationary orbits. So for the first time, Bohr introduced the concept of stationary orbits. At the same time, the angular momentum of the electron is quantized. That means the electrons revolve in those orbits for which the angular moment, that is mvr, is integral multiple of h by 2 pi, and hence the angular momentum of the electron is quantized. So according to Bohr, always the angular momentum of the orbit is integral multiple of h by 2 pi. That means the electrons revolve in those orbits for which angular momentum is quantized. M is the mass of the electron, V is the velocity of the electron, R is the radius of the orbit, N is the orbit number, H is Planck's constant. So H is equal to 6.625 into 10 power minus 27 erg second, or it can also be expressed as 6.625 into 10 power minus 34 joule second. At the same time, it is possible for the electrons, so that means electrons jump from the higher orbit to the lower orbit, or from the lower orbit to the higher orbit. So the energy is absorbed or emitted when an electron jumps from lower orbit to higher orbit, or from higher orbit to lower orbit. Change in energy can be calculated by using the formula delta E is equal to h nu, where nu is the frequency of radiation. And always delta E is equal to E2 minus E1. So the change in energy can be calculated by using the formula E2 minus E1. Always E2 is greater than that of E1. These are the important postulates of Bohr's atomic theory. Coming to the merits of Bohr's atomic theory, it beautifully explains the stability of an atom. So, once again, if we consider the structure of an atom, here the electrons are revolving around the nucleus in circular paths. So, whenever negatively charged particle is revolving around the positively charged nucleus, always there will be some force of attraction between the nucleus and the electrons. So, this attractive force is exactly balanced by the centrifugal force. Centrifugal force means it is the force by which the circulating negatively charged electron will try to move away from the atom. So these two forces are exactly balanced, and hence on the whole atom is stable. So in that way, Bohr's atomic theory accounts for the stability of an atom. It beautifully explains spectrum of hydrogen atom and hydrogen-like ions, especially helium plus lithium plus 2 ions having only one electron. So, Bohr's atomic theory explains the spectrum of hydrogen atom and also the spectrum of ions containing only one electron. It is also possible to calculate the radius of the orbit by using the formula 0.529 into n square by Z Armstrong units, where Z represents the atomic number, n represents the orbit number. At the same time, it is possible to calculate the energy of the nth orbit by using the formula minus 13.6 into Z square by n square electron volts. So, in that way, it is possible to calculate both radius and energy of the hydrogen atom and hydrogen-like ions containing only one electron. Coming to the limitations of Bohr's atomic theory. Bohr's atomic theory fails to explain the fine spectrum of hydrogen atom. So it fails to explain the fine structure of hydrogen atom. Bohr's theory fails to explain Zeeman effect. Zeeman effect means the splitting of spectral lines in a strong magnetic field. At the same time, it fails to explain Stark effect. Stark effect means the splitting of spectral lines in an electric field. It fails to explain the formation of chemical bonds. It also fails to explain the quantization of angular momentum. At the same time, Bohr's atomic theory cannot explain the spectrum of atoms or ions containing more than one electron. Best examples are helium, lithium plus ion, etc. So these are the important limitations of Bohr's atomic theory. If you like the video, don't forget to like, share and subscribe. Thanks for watching. Have a nice day.